Hello, everybody. Thanks for being here, for joining us again with another workshop. And I guess some of you have attended the workshop I held last year, an introduction in using R. And this is now kind of a follow-up workshop. As Bastien already said, I'd like to give a hands-up workshop on how to develop simple apps with R Shiny. Shiny is a framework for R. So if you attend this workshop, I assume that you are somehow familiar with R or at least another scripting language, and that you probably are not very familiar with Shiny if you already have quite some knowledge with the Shiny framework. You might not learn much new now because this is an introduction into Shiny for R. Before we start, you could, if you have your own computer and, for example, R Studio installed, you could clone the GitHub repository you see here. There are all the examples I will talk about. You could either clone this, or you could go to mybinder.org and launch the repository there. Although today mybinder.org, which is a free service, seems to be a little bit too busy. So I had some problems using the service today. So you could try, maybe it will not work, but anyway, we will record the session so you could easily later watch the YouTube video and go through all the steps later using either your local computer or a cloud service as mybinder.org. So if you go to mybinder.org, you would write the repository name here on the left side. I marked it and then click on launch. So you could try this now, maybe it works. If not, then either clone the repository to your own computer or just try it later and just watch now. So I will first give some information about what Shiny actually is. I will show you some examples. I already posted the links in the chat, but I will, of course, also show the links here in the presentation. And then we will start with easy examples to learn how to create a simple application with your data using R and Shiny. Shiny is a web application framework for building interactive web applications in R. It is free and open source. And the initial release was in November 2012. Of course, there has been a lot of development since then, and the development is still going on. So the R framework gets more complex all the time. The advantages of Shiny are that you are able to do very fast development without knowledge of HTML, CSS, or JavaScript. Of course, knowing some of these can help you to even improve your application, but you can create a fully working application without any knowledge of these three languages, which are normally a basic for creating web applications. R Shiny is, though, very good for prototyping and can also be seamlessly implemented into R workflows for reproducible research. Yeah, let's go to some examples. So R and Shiny is quite a popular framework also in hydrology, and a lot of people use it to create apps. Here's one example from our colleagues from the UK Center for Ecology and Hydrology. They have created a hydro drought explorer, which allows you to explore historic hydrological droughts in the UK. Another example is from our working group from the Global Runoff Data Center, an application to explore the freshwater fluxes into the world's oceans. Our colleague Erwin Rottler, former PhD student at University of Potsdam, has created the Hydro Explorer, which is an analytical tool for regime changes using GRDC data as well as other runoff data for the whole world. Or another nice example from the colleagues from New Zealand is an application that displays a lot of information about New Zealand rivers, water quality, water quantity, and so on. Yeah, and after these examples, we immediately go to our first exercise we will do together, of course, and that is creating a new Shiny app in RStudio. So I will change to RStudio now. And yeah, we will together create a Shiny app, actually the default app that comes delivered with RStudio. So to do this, you go to File, New File, Shiny Web App. You give a name to the application. And you can decide if you do a single file app or a multiple file app. I normally do always a multiple file app. The background I will explain in a moment. And I will create this app now. And you see we have two tabs, one with the user interface, UI.R, one with server.R. So in one file we have the server logic, in one file we have the user interface. And this is a default app, as I said, which comes delivered with RStudio. And you can run this app. And yeah, you can see there's some data on an old faithful geyser, and you can play around. On the right side, you see a histogram, and on the left side, you can have a slider and you can change the number of bins in the histogram, and you see in real time on the right side, the histogram changes according to the numbers of bins you have chosen on the left side. So how does that work? And what are the important concepts underlying this? Let's go back to RStudio and let's have a look inside. First, we have a look to the user interface. Of course, here we call here our library, Shiny, that is included. And then we have the main function for the user interface, which is Shiny UI. It's always like this. You would never change this. And inside you have some commands to create the layout. I will not go in detail on the layout section. Many of the layout possibilities is based on the Bootstrap framework. And you can easily, with the standard commands, create fluid layouts so your app will be displayed on computer screens, but also on mobile devices. So this is possible. So this is the fluid page layout. If you want to learn more about layouts at this point, I just would recommend to check out the documentary about it on the POSIT page. Here in this line, we set a title for our app. And you see inside the fluid page, we have a sidebar layout with a sidebar panel and a main panel. At the sidebar panel, we have a output function defined. for the slider input, input function defined for the slider input. This is the input control widget. And on the main panel, we have a plot output function defined. This is where the output, the plot output, will appear later. So, and then we will check out the other file, the server.r. Here, the main function is called Shiny Server, which takes as a parameter a function with 3 parameters, input, 2 parameters, input, output, or quite often here you would also have a session parameter, which allows you later to use several parameters from you need to change the behavior of the app in the current session. And inside this Shiny Server function, we see just one function, and this is render plot. This is the render function for the plot. And inside this, you have the normal lines that create a histogram. So, and now you wonder, I mean, these is not much code, you know, and all this already creates this app. So you may wonder now, how is it possible that if I change here, immediately the plot gets recreated, because you don't see any logic. Maybe you know from other programming languages something called event handler, you know, which listens for something here to change and then calls other code to change the plot. You don't see something here. So how is it possible that it works? And the main concept here is called reactive variables. The reactivity is a key concept in Shiny 4R, and it allows the app to react in real time to user interactions. So input variables can be adjusted by the user, triggering updates in output variables. And Shiny uses internally a reactive graph to manage these dependencies. So reactivity makes Shiny apps highly interactive and easy to code. And let's see now where is the reactive variable here in this code, and this is this one. So input $bins, that relates to the input widget, which is defined here. This is the input widget. It's called slider input. That creates the slider we saw. It gets a name. This is the first parameter, so it's called bins. Could be another name, but here the name is just bins. And these input widgets or input variables, they always have this reactivity. So they are reactive variables. That means that inside a reactive environment, and so-called reactive environment, if the reactive variable changes, the whole code here gets evaluated. That's the whole point. It's at the beginning maybe a little bit not so easy to understand the concept, but if you start working with it, and we'll do in a moment with our own examples, you will get used to it really fast. Okay, besides reactivity, we have these other concepts. One concept is the use of so-called control widgets, like the slider we saw. So control widgets are interactive elements in a Shiny app that allow the user to manipulate the input data or parameters of the app. And they can be added to the app using Shiny's built-in functions, such as slider input, select input, text input, checkbox input, and radio buttons. So I guess you can imagine how these things look. A slider input we saw, and checkboxes or radio buttons, you know, from normal web pages as standard input elements. So as we saw, these input elements or control widgets are placed in the UI, in the user interface file. And yeah, as I just explained, they are connected to the server section using reactive programming. So when the user changes the value of a control widget, the reactive elements in the server section automatically update to reflect the new input. So that's what we just saw. And beside the control widgets, we also have output functions. So they turn R objects into output for UI. Examples are HTML output, image output, or plot output, table output, or text output. The plot output we saw in the standard example. You can have a look again. So the output function for the plot output is defined here. It also gets a name or an ID, distplot. And in the server.R, in the server function, we find the name distplot here. So to render an R object into an output function, we use code like this. So we set output $distplot gets rendered with the render function, and inside the render function, we just need any R code that creates a plot. So if you would use other output functions like render table, then you would, instead of render plot, you would be something like render table. And then instead of creating a plot, you would here have some code that gives you a data frame or another table expression. So these were I think the most important basic concepts you need to know when creating a Shiny app. But no worries, it probably went very fast if you were not familiar with these concepts yet. But we will now step by step go into creating our own little app, and we will repeat these concepts while doing this. So you will really learn how it works. So the first exercise, or the main exercise we do in this workshop today, is to create a simple data app. And we will be using the GRDC GTN-R data. GTN-R, the Global Terrestrial Network Rivers, is the river discharge component of the Global Terrestrial Network Hydrology, GTN-H, to support the Global Climate Observing System, GCOS, and the Hydrology and Water Resources Program of the WMO, HWRP. We used this data set in the tutorial because the data policy is less strict than for other GRDC data. So I could include the data set in our repository. And please note the data policy when downloading other GRDC data, as for other GRDC data, the data policy means that you can only use it by identified access, and no commercial use is allowed and no redistribution is allowed. But for the GTN-R subset, the data policy is less strict, so you can freely use and redistribute these data. So step one now is that we download the GTN-R data. I already did this, so you don't have to do this now. But anyway, I will show you again our GRDC data portal and explain how to download data there. Unfortunately, we don't have the possibility yet on the portal to download like the GTN-R subset directly. So what you should use at this moment is to find the station catalog of GTN-R data. yeah, you would download it here. I will not do it now because I already did it, but you would download the data, the catalog here, and then you could copy all the station numbers that belong to GTN-R in this search field. And so then you would filter and would only have the GTN-R data. And if you would have done this, you would simply select them all and then download this data directly. Okay, as I already, where are we here? As I already did this, I'll go back to, yeah, so this data is already in the repository. So we can go to step 2, reading data as R objects. So now we'll change to RStudio. And if you have cloned the repository, you will see in the repository subfolders. And in the subfolder examples, you have for each step, you have the according R code, so you can follow each step and try it out on your own later. So later with this, you have a good basic to start developing your own Shiny app. So first step is we read the data. We use the package SF for reading the GeoJSON file. So in the downloaded data, you have two files. One is a GeoJSON file with the shapes of the basins, and one is a netcdf file with the time series, run of time series of the GTN-R stations. So we use GeoJSON to we use the package SF to read the GeoJSON file, and we use the R package rnetcdf to read the netcdf file. So I'm open now the file. I close UI and server from the example, and now we have the file read data. And yeah, this is standard procedure in R to read data. So here I have to stop the app, which was still running in the background. So now we can just execute these lines, and we read both files, and we can have a first plot just to see what's inside. So you see, aha, here's some basin geometry, so that works. And we can also print the metadata of the netcdf file. You see 2 dimensions, the time for each time step and the ID. So there are 314 stations inside, and then you have a number of variables. And the ones we will use now is the runoff mean, so the actual values of runoff. And we will also use the GRDC number of the station, which we find somewhere, station name. No, station name. I think there should be another one. Yeah, can't see it right now. We will come to it later. So, but we have also river name, station names. So there's a number of metadata in the netcdf file. To get the values, we use functions from the rnetcdf package. So what I do now is that I create a time series. I just get the values. In this, as an example here, I will take the station number 4, extract the values from the netcdf file and write into the values variable and extract the timestamps as well. And as we could see in the metadata, the units, the time units are days since 1st of January 700. So to transform these timestamps into date objects, I just add these numbers to the date, 1st of January 700. So then I have a vector of timestamps as date objects. So, and with these, I create a time series. Yeah, you might be already familiar with different packages for time series in R. So here I use the package zoo to create a time series with the values I extracted and the respective timestamps. And if I do a very quick draft plot just to see if there is some data, yeah, I see, okay, it worked. So now that was the first step. We have now our data as our objects. Let's go to the next step. Step 3. We want to display the basin shapes as using leaflet. Leaflet is a JavaScript library for interactive maps. We will use it later also for our Shiny application. And the R package leaflet allows to integrate leaflet maps in R and Shiny. So at the first step, we just will use it in R, and then after we will do the same for a Shiny app. So again, I will open the next step. This is now step number 3, I assume, yes. And here we have the file render basins.
Now I'm seeing something.
Hello? Okay. I heard somebody talking. Okay, I'll just go on. I assume everything is okay. If there is some problem with the connections, please let me know. Yeah, so we have the script render basins. And I copied the important lines from the last script, so we don't need the last script anymore. I use the library leaflet here. Again, I read the data, and I also read another file which is also included in the repository, and this is also a GRDC file you can download on the GRDC webpage. And this is a layer for the river network, so that we have a little visual improvement, that we don't just see the basin boundaries, but also some rivers. So I read these 2 files. And yeah, and then I create a leaflet map. And I will not, I think I explained in my last workshop, I worked already a little bit with leaflet, so I will not go into detail here. So you might remember how to create a leaflet map. And in a moment, we should see the rendered leaflet map with the shape as layers in the viewer. Takes a little bit of time, but there we go. I also put a OpenStreetMap as a background. For some reason, it doesn't display the map in the preview here in our studio, but in the moment when we do this in the Shiny app and display it within the web browser, we will also see the background map. But you see, we already see the 2 layers we added, our basins downloaded from GRDC data and the river network. So we go to the step 4 now. We integrate the whole thing into a Shiny app. And for integration of the map, we use the output function for the widget leaflet output and the render function render leaflet. I open step 4, yes. So we can close the last file. And again, we have 2 files, and they're actually quite simple. This is our user interface, which right now I removed all the stuff from the default, from the standard or Shiny example. And now we have, for the user interface, just a title panel and a leaflet output function where our map will be displayed. And in the server logic, into the server logic, I merely copied the lines we just tried out in step 3. The only difference is now that the map, the leaflet map, the creation of the leaflet map is now put inside the render function. Remember when I explained for the standard function how it works with the render function, we had a render plot function to render a plot output, and there we had to put inside the render function some expression that produces a plot. And so now we have a render function which is called render leaflet to produce a leaflet output, and so we have to put inside an expression that gives us a leaflet map. So that's that's all the difference, but the rest here is just copied from step number 3. And now we can run the app and see what happens. Takes some time to load, I assume. Yeah, but there we go. Here we see the map, and now also including the map tiles from OpenStreetMap as a background layer. And now you can have an impression of the coverage of data that is really freely usable at GRDC. And yeah, and these basins are here, the green polygons. After doing this, we go to the next step. And now we want to plot a time series. We already read the time series data, remember the netcdf file. Now we also want to plot it with another JavaScript library with dygraphs that we can later use in the Shiny app as well. So now let's go to step number 5. And we will plot the time series. Again, I copied the lines that read the netcdf data. So the only new thing here is here in the line 20 that we call dygraph with the parameter ts, that is the time series we created. And here are just some labels for the X and Y axis. If you run this, again, in the viewer, we should see the plot. And as dygraph is an interactive JavaScript library with which you can create interactive plots, we even here in the preview viewer, we can already interact with the plot and zoom in and zoom out. So that's quite easy. So now we go to step 6. We integrate the dygraph object we just created into the Shiny app. And for integration of dygraphs, we use the output function for the widget dygraph output and the render function render dygraph. So this is all in step number 6. Again, we have the server and the UI function. And comparable to the last Shiny example with leaflet, here I have just an output function for the user interface, but instead of a leaflet output, it's now a digraph output. And again, here in the server function, I have all the lines that I used in the last example to create the time series and to plot it. And again, the only difference is that I put the creation of the digraph object here, that I put this inside the render digraph function. Okay, I have some, that's just old thing with encoding. So I had the wrong encoding, but that shouldn't be a problem. Just try it like this. Yeah, now it should work. Yeah, so now we have integrated the digraph object into our Shiny application, or into another Shiny application. Okay, so of course we want to create some more interactivity with the Shiny application. So next thing we would do is to combine both widgets, so the leaflet app map and the time series, into one app. And this is rather straightforward. I go to step number 7, where I have prepared this for you, of course. So here in the UI, in the user interface, I just have both the leaflet output and the digraph output. And these are here just separated by a horizontal rule. So this is actually just the HTML tag HR. So for many HTML tags in Shiny, you find a function that creates you this HTML tag. So this is just a horizontal rule. And on top is the leaflet output, and at the bottom is the time series, the digraph output. And in the server function, also, I just put both things together, one after the other. So the same code we just had, just combined now. So again, I will run the application. It takes some time again to load. But there we go. Now we have both elements. Now we have both elements in our Shiny application. So, okay, that was just putting these things together. Yeah, but then wouldn't it be nice? I mean, now we have displayed these data, but wouldn't it be nice to have some interactive elements? I still have the one time series, I think the 4th time series of the whole data set, which is just statically loaded. Of course, that's not what we want. What we would like in an app is that the user can, for example, click on a basin and then having displayed the respective time series that belongs to the basin or to the gauge. So that's what we want, and that's what we will do in the next step. So let's make it interactive. That's step number 8. Again, I close everything that has been before. And step 8. Here are the 2 files for last step, where we put some interactivity to our application. In the UI section, I think nothing has changed. We still have the 2 elements. But here, something has changed, and this we will have a look together what we changed here. At first, I needed a function to dynamically extract the time series from the netcdf file according to the station number. So I created this function, which is actually the same code as used before to extract the time series, but just now in a dynamic approach where you have the parameter for the GRDC number, and it just finds the right index and then returns the respective time series. So that's all. I added a observe event. And this observe event function is listening to if somebody or if the user is clicking on any of the polygons. This is if you create a leaflet map and if you include a shape file, you will always have this, or in general, if you have a leaflet map, you will always have this possible event that a shape is clicked. So my map got the name or the ID my map, and so if this is the name, then you can always use the reactive variable name of the map underscore shape underscore click. In this case, my map underscore shape underscore click as a reactive input variable. So this is this. And so as soon as the user clicks on the shape in the map, all the code here will be evaluated. And so what we do here is we have a get a click on the shape, and this click event will give us a variable we can use, and inside this or an object, and this object has some parameters, and one of the parameters is the ID of the shape we've clicked. And to include the ID, I added one line to the leaflet command where I create the leaflet map, and this is this. I give a layer ID, and so I tell them, okay, as layer ID for each element, you should use the variable, the column GRDC number, which is part of the GeoJSON file. So then each polygon has a unique number, the GRDC number of the basin, and this one we can use here in the event. And what we do then, so somebody clicks, and then we call the function to get the time series, the function I have here, using the GRDC number as a parameter, and then so we can get the respective time series from the netcdf file, have it returned, and then use the return time series as a parameter for creating the digraph object. All right, so, and now we just need to find out where there is, okay, this belongs here, I think. Here's the bracket missing, right? maybe, yeah. Okay, looks good. So we start the app and see if it works. Okay, here's the map. And now let's click on the basin. Yeah, and you see that it works. So I clicked on the Congo basin and I get in the digraph object or output function, I get the time series of Kinshasa gauge displayed. And so I can take any other. Yeah. And yeah, maybe here I also added, this is another thing I added, simple thing I added as a title parameter for the digraph. I added the station name and the river name. So this is another change I did here. So what you see here, this variable p is the data of the basin I clicked with the ID, and then of course I can just use my data frame, or actually it's a spatial polygons data frame, basins, and find the row where the GRDC number is equal to the GRDC number of the basin I clicked, and then I access the river column and combine this with the station column to have the title in the app. So yeah, so this should be an introduction into the basic approach to create applications with Shiny. Of course, there's much more to learn, especially when the applications get more complex. So now you could have your own ideas how to work on this application. For example, you could work on the layout, maybe add some menu to add some more information or details. Maybe you would like to, add some calculations to calculate some hydrological indices on the time series and so on. So your imagination is the limit. So you can now use this as a start and go on and improve the app if you want, or just use this as a blueprint to start to create your own application with your data. But I hope that you have learned, and that's the I still have some slides, I see. Okay, so we come to the takeaway messages later in a moment. Anyway, I hope you have learned that it's rather easy to create applications with R and Shiny. So don't hesitate and try it on your own. And now I will just give some more information on deployment and on some alternatives maybe. So as I said, R Shiny is really good for creating prototypes. There are a number of services or some services you can use to deploy, so to publish your application. One really nice is Shiny Apps IO. This is a cloud service, and up to 5 applications you can deploy there for free. If you are a little bit familiar with server administration, you could use the Shiny Server application, which is open source, to install your own Shiny server in a Linux or Windows environment, if you have your own server or you have the ability to get a virtual server in the cloud, which is yeah, not a problem, of course. If you happen to work in a bigger company or somewhere where there is the need for some bigger solution, because maybe you have some applications that will be used a lot, so they if it needs to be scalable, you could consider to get POSIT Connect as a server application, which is quite pricey, but yeah, for big administrations or big companies, that could probably be an option. And an option that combines open source and scalability, of course, is to use the open source Shiny server and combine it with virtualization and with Kubernetes containerization. But yeah, so for the beginning, I guess it's really easy to create your app, and you can use Shiny Apps.io to share the application with your colleagues or with the scientific community. And yeah, some alternatives. One very interesting development is Shiny for Python. If you are not very familiar with R, if you are more working with Python, there has been the alpha release in last summer, and I think now there has already been some more development. So I already tried it, and it also works fine. So you can use the way of creating web applications now also in Python. Of course, the syntax is a little bit different, but the general approach is similar. And also, if data can be pre-processed and you don't need like real-time calculations, it's of course always an option to create static sites with R Markdown and deploy these, because then you wouldn't need an R server for deployment, and you could just use R on a workstation to create, to pre-process your data, create static sites, but for example, also using JavaScript, but then deploy these sites, and then you would only need yeah, a standard HTML server, and you would not need a server with R running to deploy the application or the data to your clients. Yeah, so we come to the takeaway messages. With Shiny, you can turn your data into interactive apps. I hope you have seen this, and I really hope that you realize that it's rather simple and that you can have an easy start with that. You can follow all steps by rewatching the workshop on the Eurofriend YouTube channel, and also, of course, by cloning the repository. Here is the link again, the GitHub repository. So you can clone it and then open all the scripts in your also local RStudio environment, and it's a good starting point. And of course, if you have further questions or ideas, you can always contact me. And yeah, thanks for your attention. And if you have any questions, feel free to ask now.